Hello, this is video W, and I'm sorry if my appearance freaks you out. I don't even know where my glasses are at this point, but I'm still reading source code. You know what? I don't like the way I started that. I'm not still reading source code. I am reading source code. I'm not still doing anything. Even though it's the same example program, I hate making those connections. We are starting fresh from scratch. Somebody may or may not write an example A program that uses TV objects. I don't know. I don't know. That's none of my business. My business is this. Someone set up an ADT. They listed all the operations they wanted for a thing called a TV object, and they passed that off to me. I am a developer. I am developing. I am responsible for inventing the TV data type. It's all on me. How is that going to be used in the outside world? Maybe it's going to be part of a larger object, maybe an iPhone object that has a TV object inside it. Oh, maybe they're going to have a bunch of different TV objects to represent what's on sale at Best Buy. I don't know, I don't care, that's none of my business. Do you see how the wall goes both ways? The main program has no idea what's going on inside a TV object. The TV object has its own little private world to take care of. It has no idea what's going on in the big, nasty outside world out there. All it knows is it's got to take care of its business all by itself. It's responsible for keeping an eye on its private variables, responsible for making sure the functions behave as advertised. So what we're going to talk about in video W is this file, Tv.h, also known as the TV, I still can't spell TV. That is so pitiful. The TV interface. In C++, you implement interfaces as .h files, also known as header files. This is what you're advertising to the world. The contents of Tv.h are on a billboard. If you want to use a TV object, here's how you do it. Here's all the stuff you can do. Now, I'm going to start with kind of a verbal aside. Last time, I think, I talked about preprocessor directives, and there's even more in this one. But if this is comforting, you may accept it. The preprocessor stuff in this, you don't necessarily have to understand, but I don't like hand waving, so I'm going to go ahead and explain it anyway. But this is kind of advanced stuff, if you will, so don't feel bad if this doesn't make sense. You don't have to know it for the test, any of that stuff. There, now you're not paying any attention at all. I don't know when it's safe to start paying attention again, but I'm going to start with line 11, define debug. Define debug does kind of what it says. That's a preprocessor directive. It happens before the program's compiled. It says, define it. Make it exist. Here it is. Debug, all in capital letters, just like a symbolic constant. I hereby pronounce that debug now exists. That's what the define does. What if I commented that out, that preprocessor directive on line 11? If I comment that out, then debug does not exist. It's actually sort of like a Boolean variable. My metaphor for it is a light switch. When you say define debug, you're turning the debug light switch on. For my own reference later on, now it doesn't show up in this file unfortunately, but now throughout any of the other source code that's going to be part of the same project, I can ask the question, does debug exist? If it does, maybe I want to print out a debugging message. Maybe I want to print out all the channel and volume and everything I know about the TV. That's not something I want to do normally, but while I'm trying to get my program to work, for crying out loud, it might be very handy to see out a bunch of stuff. So what I can do is, with ifs, later on, I can say, if debug exists, then do these things. Otherwise, just skip over them. That's exactly what that preprocessor directive is for. Now, the reason I started on line 11 is because I hope, we'll see, it makes it easier to describe what on earth is going on line 7 and 8, also preprocessor directives. Line 7, if, well, there's a little bit of familiar territory there. If in def is short for if not defined. If not defined, and there's another symbolic constant looking thing, TV underline H. That is a symbolic constant sort of thing. It's just a token that means the TV header file. TV underline H, since you can't use dots and identifiers. TV underline H is a symbol that represents the TV header file. If not defined, then line 8 just turns right around and defines it. Then defined TV underline H. So if it can't see TV underline H anywhere in the project because it hasn't been defined yet, then define it. If you're the first one on the moon, then plant your flag. And that's what's going on here. If this is the first time we've seen the header file anywhere in the project, then define TV underline H. And it is now defined. And keep going, keep going, keep going, keep going. How long? Well, there's an end if on line 34. That end if matches the if on line 7. Those are called exclusion preprocessor directives. Oh my goodness. The oh my goodness is not part of the term. I appended that myself. What are those doing? Well, it's exactly like the planting flag metaphor I just said. If we've never seen this header file before anywhere in the project, then look at it. Define. Put your flag in the moon, TV underline H, and look at all this stuff. The class TV and all those prototypes and private data and everything. Now, later on, maybe I'm going to go back to my watch. Maybe your iWatch or whatever those things are called, maybe that has a TV object inside it. If it does, it's probably also going to include Tv.h. You can't define a new data type that has the same name more than once. If I've already got TV defined as a data type, I can't define TV as a data type again. So the question that line 7 is actually asking is it true that we've never been here before? If we've never been here before, then stake your claim, say I've been here, and keep going, and look at all this stuff in this file. If I get here again because it's included again somewhere else in the project, it's going to say, you know what? Somebody's been here before. He already knows about this data type. Just ignore everything down through the line 34 end if. It's as if we've included the file for nothing. It's already been seen. You can't define the data type more than once. Okay. I said it was advanced and you didn't have to know it, and I've already spent way too much time on it. So you need to start paying attention at, yikes already, 7.5 minutes. Here's the stuff that we're here for. This is line 5. If you look at the header, this needs header comments too. This is the interface, TV interface. Got that, check, got that. A new thing, line 13, class, changes a special color. That's a reserved word, of course it is. Repeat after me. A class is just a structure with functions. There. That puts us back in our comfort zone, doesn't it? I hope, a little bit. A class is just like a structure, except it's got functions in it. It's just like a structure, except it's got a bunch of other gunk in there too. Here's the other gunk. The things that we define to be or declare to be public. Purple word public on my paper. Purple word public on my paper, line 16. Public says, here it is. Here's all the stuff you can do with the TV object. We are exposing the interface. We are showing what a TV object can do. Constructor and destructor. Constructor is line 20. It doesn't look like a function at all, does it? Here's some things to notice about that. You know what? I'm even going to write that up here. Our first example of a constructor looks just like this. That is a prototype. Believe it or not, that is a function prototype. I'm going to do the comments in a different color because this is so strange and fresh and different. This is the function name. And you can't let me get away with just that. The name of the constructor. We had no choice. It must be the same as the name of the class. Function name. Name of constructor must be the same as name of the class. I'll abbreviate that. The same as the class name. Is that abbreviated? Oh! Function name. Name of constructor, the one that's going to set up a TV and get it ready to roll. I don't know what it takes, but that's gotta happen. We've got to get those TV objects ready to roll, get them all initialized and everything. This is the name of the function. And of course the void, we know what that means. That just means we're not passing anything in. No parameters. No parameters for you. Now, here's the heartbreak of this being the first member function that we look at. Perhaps you recall this, perhaps you don't. We never called this. The main program never makes a function call to a function named TV. Then why does it exist? It is called. It is called. And I'm going to violate my deeply held principles and put a line that does not belong down here, up in main. Maybe I have a TV variable called, what's a good name for a TV variable? I don't know, Motorola. I'll call it motor, short for Motorola. There. I've got a TV variable now, a TV object called motor. Hidden in that definition of that variable, strangely, oddly, is a call to the constructor. When you set up a variable of type TV, the system, the CPU, automatically calls the constructor that you provide. Now, if you're thinking, well, what if there's not anything I need to do? Fine. Empty curly brackets. You still need to have a constructor. The system is still going to look for a function called TV, of all things. It looks for a function called TV. It calls that to do any initializations that you set up. I'm losing the camera again. Good grief. But you never call it directly. Okay. Lost my train of thought. This is never called by us. We do have to provide it and put any initializations in there that need to be done. Excuse me. But we never call that ourselves. Another function that we never call ourselves. The other end of the life cycle of a TV object is when it's about to disappear, when it's about to disappear out of memory completely and be gone. That is the destructor, and it has this squiggle out front. I think that's called the tilde. I meant to look it up. Tilde TV. Also void, no parameters passed in. Oh, I didn't even say what this was. This is the constructor. This is the destructor. And to refresh your memory, well, the function name is tilde TV. As far as I know, that is the only place in C++ where tilde is valid as part of a function name. It's just how they set up the syntax. There's not any logic to it at all. That is just it. They just said, this is the name of the destructor. Get used to it. So, the destructor, again, this is called automatically by system, called by system, when TV object goes out of scope. TV object dies. I like that better. I was avoiding that word before, but the mood that I'm in right now. Call by system when a TV object dies. Clean up the mess. Dispose of the body. Free up all the storage that TV object occupied. If there's anything we need to do, if there's anything we need to dispose of ourselves, then that goes inside this function. It's probably going to be a while before we actually have to put any cleanup in our own destructors, but we'll still supply them. This could also be empty curly brackets, meaning, there's nothing special to do. Okay? Those are the first two member functions. We need those, and we put those at the top, because those always have to be there, whether we have any accessors or mutators or anything else or not. So there's the first two functions, that's line 17 and 18, constructor, destructor. Here come the accessors. Accessors, remember, can look at the state of the object. They cannot change it. How are we signaling that to the compiler that these are accessors? I bet you can guess. Look at line 20 and 21. I spy something different, generally speaking, about those from that next chunk of 4 prototypes. Playing right along, looking at the source code of Tv.h. Well, among other things, the important thing is the word const. In a different context here, maybe they should have used a different word, but they didn't. So again, we're just going to have to get used to it. The const at the end of line 20, the const at the end of line 21 means that these functions are not allowed to change the values of the state variables. They're not allowed to change the private variable values. They're not allowed to change the state of the object. What's more, they are even more restricted. Those functions cannot call any of the mutators. If you inside get channel, if you call set channel up, the compiler won't even let you get away with that. It'll tell you that an accessor cannot call a mutator. So they are really, really strict about that. You can't change a thing. You can't change the state. You can get it. And I think we can parse or reverse engineer what's going on in the rest of that. Let's see if we can. Line 20 starts with int. We're going to return an int. You know what? I bet the int value we return is going to be the channel that the TV is currently set on. Yeah, that sounds right. Get channel is the name of the function. Void, we don't pass anything in. The main program wouldn't have anything to pass in. It doesn't know anything about channels and volumes and stuff except what we tell it. So there is nothing really going on here except returning an integer and the const that says you can't change any of the variables here. That's true of get volume as well. I didn't even write any of that on the board. It almost looks like lines 23 through 26, which are mutators, it almost looks like they're going to do nothing at all. Void, void, void. Everywhere you can see anything that's not a function name, it's the word void. Void out front, void in parentheses, those mean two different things. The void out front means we're not going to send anything back. The void in parentheses is you don't pass anything in. So what do? Mutators. By definition, they're going to change the internal state of the object. And they're not even going to return true or false to say whether or not they did it. They're just going to do it. For example, line 25, set volume up. Just do it. I'm not going to tell you anything. I'm not passing anything in parentheses. I'm not going to wait for you to send anything back. You're not going to send me back the volume. You're not going to send me back yes or no, whether or not you change the volume. You're just going to do it. You're just going to do your job. So set volume up is going to change the internal state. If it's able to bump up the volume, if the volume's not already at the maximum, then that's exactly what it will do. It will change the state of the object so that the volume is 1 higher than it was before. That's the complete job of that function. Nothing else. Now, everything that we've looked at so far follows that purple word public. And by everything so far, I mean inside the curly brackets for the class. Remember, we're still inside a structure with functions. We just now looked at all the prototypes of all the functions. It really is very much like a structure that way. Here are the variables, the fields. Actually, they're not even called fields in a class anymore, even though they are very much like the fields of a structure. We only got 2 variables. We probably could have predicted that secret, but who knows? Who cares? It doesn't matter. That's our business. How we keep up with the channel and volume is our business. We're just going to keep up with it in 2 variables, int channel, int volume. Here's an extremely important point. Every separate TV object is going to have its very own channel variable, its very own volume variable, its very own set of functions that we just talked about, the prototypes. These TVs don't even know anything about each other. They can't cross-call each other, set channel up, set channel down, or anything. They only know about themselves. Once you get inside their colorful candy shell and you're inside that TV object, it can see all the private variables. It can call any of the other functions that it wants, unless it's an accessor and it can't call a mutator. It's like I said, it's an exclusive little club inside there once you get inside. How do you get inside? You have to go through the interface. You have to call one of these publicly prototyped functions. And I said that right the first time, so I'm not even going to try to repeat it. The channel and the volume, you know what? I'm going to have to write a note on the board about that. I might even write that whole thing because it's pretty small. We'll see. If I can get the marker open. Private. Once again, I apologize on behalf of I don't know how much of that you missed. I apologize on behalf of the developers of the C++ syntax. You do have to put the private variables up there in the header file. It's like we're teasing the main program. You can look at these variables if you want, but you can't touch. You can't change the value of volume, int channel. You know why? Because I hid it. I claim that it's private and that you can't see it. Even though you include the header file, You might say, well, yeah, the main program can see that. It's up there in the header with all the other stuff. Again, I apologize that it doesn't make sense, but that's where it goes. You have to say what the private variables are that are hidden inside the TV object. You have to say that in the header file. Then how do we keep the main program from accessing those? This right here, the word private. That means the main program has no direct access to variable channel, no direct access to variable volume. Who can see these? These are globally, G-L-O-B-A-L-L-Y, globally visible to every TV class member function. Exclamation point for emphasis. I told you it's an exclusive club. Once you get inside the object, once you're inside that private space, then all those functions in there can see what the channel is. Some of them can change it. They can all see what the volume is. Some of them can change that too. And by some of them, of course, I mean the mutators. Then what's the significance of this, the globally visible? That just means you don't have to, these functions don't have to have these passed in as parameters. They can see what the channel is, even with a void parameter list. They can call each other and change the channel and change the volume and all that stuff if they want to, without passing them in as reference parameters or any kind of parameters or anything else. If you are one of the member functions of the TV object, you can see these. You can see these automatically, not passed in as parameters. That's why functions like, for example, on line 23, set channel up. I don't have to pass it. I don't have to pass it the channel for it to be able to do that. I don't pass that as a reference variable to make sure that the change sticks. The change sticks anyway. It can see the channel variable because it's a member of that exclusive club over in the CPP file we haven't looked at yet. But if you're in that exclusive club, you can see these. Is that all I need to say? Oh, globally visible to every TV class. I need to be even completely more specific. This is invisible everywhere else. I-N-V-I-S-I-B-L-E. Invisible. And by everywhere else, I mean outside of the TV object to any other functions that are not member functions. Invisible everywhere else, including main, even the main program. Now that might seem unfair. Exclamation point again. The main program, if it sets up structures, you can see all the fields inside the structure. There's no hands off there. This is different. If we've got private variables inside this class, then we'll have private variables inside each one of the objects. The main program can access those indirectly, maybe, depending on whether or not there are functions in the interface to do that. But nowhere in a main program is it going to say something like Sony LCD or whatever that was. Sony LCD dot channel equals 9. It can't do that. It can't see this channel variable. It's not like a field of a structure that way. It's hidden. It's the exclusive domain of just the member functions of the class. Okay? That's actually extremely good reasons for that that would be very difficult for me to explain abstractly here. But one of them is for consistency. The idea that channel 75 is not allowed. If we expose this, if we put this as a global variable rather than a private variable inside TV, in other words, we put this outside of the class so that everybody could see it, then anybody could set the channel to anything they wanted. Even worse, if I put this outside of the class and everybody can see it, even if I put it at the top of the CPP file, or if I put it outside this class declaration in the header file, if there's only one channel variable, then there's only one channel that all the TV objects share. And that's pretty useless. All the TVs have to be the same channel. We don't want that. We want every TV object to have its very own channel, its very own volume, and nobody else can touch it. Nobody else can see it. You want to change it? Fine. Go through the mutators. Tell a mutator to change it for you. That's the only way you can do it. Now, there's one more thing I want to do about the header before we leave the header. And yeah, it looks like the CPP file is going to be its own separate video. That's fine. I'm going to put on my invisible glasses, my X-ray vision glasses, so that we can see an X-ray view of a TV object. Too bad this wasn't Video X. We'll pierce the veil of secrecy. Ooh, and see what's inside a TV object. You know what? TV object is going to be, throw that down. TV object is going to be this big. That's big. How do I know what's in there? Well, I can see all of it. It's here in the header file. It's got public function prototypes. And I could write those on the board. Yeah, that'd be a waste of time. I'll just sketch those out. There is a prototype for get channel, which I'll abbreviate get chan. With parentheses show, yeah, I know it's a function. There's also what? Get volume, abbreviate that, get vol. You can see those. That's abbreviation of line 20 and 21. All of those prototypes are public so that anyone that has TV objects can actually use it. They can call the member functions on it. That's the public stuff, etc., etc. A very deep, dark line. This is all publicly visible interface stuff, and I'll label that a different color in a second. Down here are the private parts, the private variables. And actually, another part of the private part of this object are the function definitions. That means the actual source code that you type in for each function when you're writing the functions. So variables, private variables, and function definitions. That's why I abbreviate so much. I'm a horrible speller. Gifted children are horrible spellers because they learn to read whole words at a time and they don't have to sound them out. I heard that one time a long time ago and I claim it. Okay, what do we got? Private variables. We got two private variables. Channel. And we got your volume. There they are. They're below the line. They're private. They're secret. That's below the surface. That's above the surface. What else we got? Well, we got the actual code for the get channel function. I'm not going to write that either. But that's going to be get channel and whatever parameters, if there are any. Open curly bracket, all the lines of code, yada, yada, yada. That's a private thing inside the TV object. The get volume function. Open curly bracket, do what you got to do, close curly bracket. The implementation stuff of the functions, the implementation lines of the functions, those are all private. Now, here's a reference to, well, not a reference to, that's not a good word to use, a throwback to what I said earlier before I erased the board. Let's say the volume is currently 6. Then even if this has an empty parameter list, get volume can say return volume and send it back if they want to. And that's probably what they do, I don't remember. But the get volume, and the point is the get volume can see these private variables up here without having them passed in as parameters. Anyone that is one of the functions, member functions inside the TV object, they can see these private variables. They can see what the values are. Get channel can see that we're currently on channel 2 if it wants to. So if get channel wants to send back what the channel state variable is right now, then it can send back the 2. It can see it, even though we don't pass it in as a parameter. So it was fortunate that I put the variables up here. You can tell these functions can see. They can see the variables they need to see. I can see you, even though nobody passed you into me, because you are part of me. There's some implications of that. Let me go through some implications of that. And I'm not going to write on these on the board, but listen carefully. One of the implications is these variables are not like local variables at all. They are permanent. As long as the TV object is alive and well and kicking, then there is permanently a value in channel. There is permanently a value in volume. Those do not come and go with the function calls with our old-fashioned functions that were not members of any class. Let me say that again. That's an important point. The private variables have values that persist. They exist independently of any particular function call to a member function. So if the volume is 6, then the volume will stay 6, whether the main program calls any of the volume functions or not. It doesn't care. This has a state. That's why it's called the state. The current state of the object is the collection of all the values of the private variables. And that state persists between function calls. Somebody calls a function, they get volume, I send back 6, and then they go back. The 6 is still here. Doesn't come and go. That's a big deal. That's a big deal. Because with local variables, we didn't get that. With local variables inside functions, and these can still have local variables. Maybe get volume needs an integer variable called temp, so it can do some calculations and figure out what the volume really is. Maybe we're going to figure out the volume in dog years or something like that. So maybe it's got an integer variable temp. That will come and go as the function is called and the function goes back. The private variables that are defined where we are here in the header file, these persist. Those exist. Now I am repeating myself. Maybe it's for emphasis. Maybe it's just because I forgot. But we have a channel and a volume variable that exists for that TV object as long as the TV object is around. And the values stay the same until acted on by a mutator. That does sound familiar. I think I might have said that abstractly before. Oh, I was going to switch colors and write stuff on here. This is the interface up here. And it's visible to the world. It's public. I've already got public up there. I'll just say everybody can see this. This is the implementation that we'll look at in the next video. Only visible inside the object. All the things below the line, the actual implementation of the functions, the values of the private variables, you've got to actually make a call to a function through the interface and be inside this object down here to be able to see or change any of this stuff. Okay? I don't know what else to say about this, except the main program, which is long behind us now. That was a previous video. The main program always has to go through this. You always got to go through the front door up here. There's several different doors, but you still got to use one of those to get down here and actually do anything to the TV object. Why do I feel that description is still insufficient? Take careful notes. Listen to it carefully, maybe more than once. Try to get all the terminology down. And just Zoom me out. I know I wasn't available much for Zoom yesterday, and I apologize for that. But I'm going to be monitoring the request for Zoom meetings much more regularly today, tomorrow, and for the rest of my life. So I'll see you online.